Hello, a warm welcome to all our viewers. I am Subhashish and today I'll be speaking about modernizing your API ecosystem by migrating IBM API Connect to AWS, specifically transitioning from traditional on-premise deployments to a cloud-native architecture on Amazon EKS. This session walks through the architecture, migration strategy, operation model, and future roadmap, helping you understand not just how to move, but why it matters strategically. So let's discuss the agenda today. So what we have for our session, why do we need to move to AWS? Architecture overview, reference design, advanced topologies when we talk about the hybrid and multi-region topologies, migration and operational considerations. The goal here is to connect technical modernization with business value. So moving on, the why behind on-premise constraints. On-premise API Connect environments face rigid capacity limits, be it provisioning hardware or scaling requires a procurement cycles, patching VMs is operational heavy. So on AWS, when we compare, we move to infrastructure as a code, IAC, auto scaling Kubernetes as clusters, native integrations with Lambda, S3 and CloudWatch. But this is not just a lift and shift, rather it's a transformation from infrastructure maintenance to API governance, agility and innovation. Now, on-premise to AWS, what exactly changes and why? So there are several architecture shifts that takes place. If we talk about elastic scalability, gateways and subsystems scale dynamically across multiple availability zones. Kubernetes native deployment instead of appliance or VMs, Epic runs on containers. It runs as a container on EKS using operators. Container registry integration, images are securely stored in Amazon ACR. Coming to fourth, the cloud native storage. Persistent volumes use EBS, Elastic Block Storage. Analytics and backups can be easily offloaded to any of the S3 buckets. Integrated observability. Logs flow directly into CloudWatch, CI/CD pipelines, automation, API publishing. This creates a resilient, automated, cloud-aligned deployment model. So these are all the benefits that we get when we move from APIC on-premise to AWS. Now, what runs on AWS? All four API subsystems, be it the management gateway, the management pane or the gateway, the developer portal, and the analytics, all each of these run as a containerized workloads inside Amazon EKS. IBM's Kubernetes operator automates, from the installation, upgrades, certificate rotation, lifecycle. So each of these tasks is handled. Cert Manager is handled from the certificate provisioning. AWS native services complete the setup. For ECR for images, EBase for persistence storage, CloudWatch for logs, container insights for metrics. This gives us consistency, automation, and high availability by design. So now let's move on to the supported versions and the prerequisites. So basically API v10, API v12, all these support this integration of API Connect with AWS. So migration to AWS is an ideal opportunity to upgrade from legacy versions into a fully supported LTS, long-term support release, positioning the platform for future V12 adoption. Moving on. Here we can see a reference architecture. This slide shows a production grade deployment. The key components, if we can see, Route 53 for DNS routing, application load balancer, EKS cluster, ECR S3. This architecture ensures high availability, automatic failover, resilient ingress handling, cloud native storage durability. This is the strength that we get migrating our on-premise architecture to AWS. Now comes the major part, the traffic, security, and connectivity, which forms the core of any integration. All external traffic enters through a managed AWS load balancer. So requests reach the data power gateway runtime where the TLS MTLS termination occurs, OAuth and OIDC are enforced, JOT token validation is applied, threat protection and throttling policies are executed. From there, APIs connect securely to the backend. AWS native services like the Lambda, SQS, DynamoDB, RDS, microservices within the VPC, on-prem systems like VPN or even direct connect. This enables hybrid connectivity without redesigning your backend systems. Your system can still be the same, but it can leverage all the features that is provided with AWS. Now coming to hybrid and multi-region deployment topologies. Enterprise rarely move everything at once, as we are all aware. It is all a step-by-step process. A common strategy is a hybrid deployment. Gateways and management on AWS, while the backend systems still remain on on-prem. For a global scale, Multiple AWS regions can run independent of API-C clusters. Route 53 provides region-aware DNS routing. Config sync replicates the organizations, applications, credentials, and subscriptions. This support active or active standby disaster recovery as per the organization standard. It can be covered both. Moving on, the migration path from on-premise to EKS.